dot predict of xtrain. Okay, so sir, why you are keeping the name as base model? Why you are keeping these names? Each time you are selecting different names. Why? You may ask this question. Variable names, why you are selecting this one? Model names also you are selecting different. Miss, if I select only one type of model name in all the models, you will also fix that. Oh, this is the model name I have to keep. The students will fix like that. If I keep in different models in different names, means oh, model name is not constant. Any model name we can keep as per our interest. We can keep. Earlier in the previous batch, when I have trained, I have kept everything as a common name. They have fixed that model name is this one only. Sir, you told that model name should be this one only. Some students asked me that question. I was literally shocked. Oh, if I follow that means you'll also follow the same way. Na? For example, if I don't do this predict on the train data, they think that, oh, for PCA, no need to predict on train data. They'll fix like this. When you have to apply on the train data, you have to check the train accuracy. To check the train accuracy, you have to predict on the train data. You don't want to check the train accuracy, means why you no need to predict on the train data. That is the minimum thing. Na? They'll not understand in this way. Sir has not applied for PCA, means we no need to also apply for the PCA. For PCA, no need of train data, train accuracy. No need to check the train accuracy. They'll fix like this. That is the reason I'm writing that one also. Okay. So I'm going to print with respect to accuracy score on the y underscore train versus y pred train. Okay, now I'm going to get the first one is train accuracy of 100%. Decision tree is 100% only. Na? Nothing to shock. By default, it will be 100% only. So here 100%, and for this, it is this one. Okay, 0.97. For the last line, if you don't write print also, automatically it will print in the Jupyter notebook. Don't get shocked for that. I'm not using the print. Above you are using print. Don't think like this. If you want, I'll write print also for this one. Don't ask that question. If you ask this type of basic silly questions, means I'll get doubt myself whether I'm trying or not. Okay. So now after applying the PCA for the same data set, I'm applying the PCA. So same XY. Okay. Same X train, Y train, the same thing. The same XY, same train test speed of test size of 0.2, random state of 0, the same thing. But this time I'm going to apply the standard scalar. For applying PCA, first I have to do the standard scalar. That is, first I'm going to fit and transform on the train data. Then I'm going to use only on the transform on the test data. After that, I'm going to apply the PCA. PCA from sklearn.decomposition. Import PCA. Now PCA n components is equal to 95, 0.95. The meaning of that means 95% contributing only lambda values you separate, which are contributing 95%. I want up to 98 means whichever the lambda values are contributing the 98%, it will be separated. Right? So here I'm going to write 0.95. Now I'm going to apply on the xtrain underscore PCA, and I am going to fit on the xtrain data. After this, I have to apply the PCA. Na? Now, if you apply if you check this one, see, so total 10 columns are contributing your requirement. If you add all these 10 values, it is saying that you have only 10. So if you ask the shape, what is the shape? Is only 10. Sir, I want with respect to 98%, up to 98. Again, do this 98. Now, 11th column is adding with respect to the remaining part. You want up to 95 only. 95 is sufficient for you. Then only 10 columns are sufficient. Now you are going to fit on the data of xtrain underscore PCA. Means only 10 columns you are going to give as the input. You are fitting only on 10 columns, not on the 13 columns. 10 columns. That 13 columns has been converted to 10 columns, and you are going to use the same classifier. Whatever you have used above classifier. Above, what is the classifier? Oh, decision tree classifier. Okay, let us copy the same decision tree classifier. We'll use the same decision tree classifier so that we'll see the difference. Why to use random forest? Okay. So same decision tree classifier, and I'm going to use this one. Once again, I have got the same accuracy. If the accuracy remains constant, either you will be having with respect to time will reduce or accuracy will increase. Any one will happen. For this data set, neither accuracy has been increased, but time will reduce. For example, you have used in terms of random forest classifier. Okay, same 92. Miss, it is not having any impact on this particular thing. Is that clear? Either accuracy will increase or this one increase. Okay, you can try with another data set. Earlier we have worked on the different multiple data sets. Now you go and apply for that data sets. You go and apply the PCA. You can find the difference. Okay, clear? Whatever the logistic regression we have applied for that data set, and decision tree classifier one data set, for KNN one data set, multiple data sets we have taken. For all the data sets, now you apply the PCA and you apply the KNN algorithm. Apply the PCA, after that you apply the logistic regression. PCA is nothing but not the model name. PCA is just converting the futures only. Model fit on the X train, Y train, you have to do on the model only. Just it will do the number of futures will be reduced. This is also one of the part of data pre-processing only. Is that clear? Done? Any questions? Now, in the last class, I have told you that when compared to any other institute, something like this and BITS plan, and I have written that one and I have forgotten. I have stopped there itself. So that same thing I'm going to continue now, which is with respect to, okay, in BITS Pilani, the course, whatever the course we are having in the BITS Pilani, just I'm opening the course. Okay, here if you observe this artificial intelligence and machine learning post-graduation program, which is of 11 months program. At the starting also I have shown you the same thing, which is the course fees of 2,45,000. Okay, now here if you observe this program curriculum, okay, first one is regression. Everyone can read that regression, and is there any one letter is missing in that? Can anyone tell me? If any one letter is missing also, please let me know. Read from the starting. If one letter misses also, please let me know. Did I told everything? Here only lasso ridge is included. We have included the elastic net also in our case. Interpretability of regression models means identifying which is the best model. You are applying all the models and identifying the best model is nothing but interpretability between the models. Every letter is okay. Now, this particular course, whatever the course fees is there, okay, course fees of 2,45,000, 2,45,000, including the GST amount. Okay, now divide by courses of regression of 5 weeks, 4 weeks, total is 9, 9 plus 9, 18, 18 plus 7, 25, 25 plus 5, 30, 30 plus 6, 36. 2,45,000. Your course fees of 2,45,000 divide by 36, which is per week 6,800 rupees per week. They are collecting. Out of for regression 5 weeks means just multiply this 6,800, whatever the value is there, the 6,800 into 5, which is 34,000. Whatever the regression we have discussed, the same thing you want to learn in the BITS planning is 34,000. There also I will take the classes. Okay. Now, course number 2. First regression is 5 weeks of course, which is 34,000. Okay.